Hello there, it's Andy Ewens from FormaServe once again. In this video we're going to go through CL Programming Enhancements. When launched in 1988 through to version 5.3 in 2004, IBM had made no enhancements to CL programming. We were thought we were burdened with the same CL forever. We were stuck with restrictions like only being able to open one file in a program. We cannot use printer or ICF files, use sub-files within display files, nor use program-described display files. Then IBM got very busy on the CL front, and we now have some many great programming features. They have included lots of functionality that up to now was only available in other languages, RPG, COBOL, etc. And now we have these in CL. Fantastic. The first enhancements IBM gave us was in version 5.3. We had new variable types, using more than one file in a program, and some structured programming features. Let's go through these one by one. Let us take a look at the first one on the list, integers. An integer is a whole number, not a decimal, but can be positive, negative or zero. Here we can see two variables defined as integers. The first one, called count, is an integer, whereas the days variable is an unsigned integer. It can only store positive whole values, no negatives. If we don't specify any length parameter on the declare, by default it's given a length of 4 bytes. Now on to the next one, which is using more than one file in a program. Right up to version 5.3, if we needed more than one file in a program, we had to have multiple programs. Open one file, call another program that opened another one, so on and so on. Well, not any longer. We can now have a maximum of 5 files in a CL program, at last. On the declare file command, we have the name of the file to be declared. This is the object name of the file, the name of the file that's on the disk. The next parameter, the open ID, is the name we are going to use within our CL program. This name is then used for the rest of the program. The next enhancement is structured programming. The first loop command we're going to take a look at is the do for command. This is very similar to a for loop in other programming languages. The do for command processes a group of CL commands 0 or more times. Let us take a look at its parameters. The first parameter is variable used to control the loop. This variable must be an integer type. The second parameter, the from value. This specifies the initial value of the CL variable used to control the loop. And the third and final parameter specifies the final value to compare to the control variable. The loop control CL variable will be compared to this final value before processing the group of CL commands between the do for and the corresponding end do statements. The next one on the list, the do until command, processes a group of CL commands at one or more times. After the commands in the group have been processed, the condition is evaluated. This command only has one parameter, the condition parameter. This specifies the expression that is evaluated to determine a condition in the program and whether the program is processed again. Let me explain the example we can see on this page. On the first line of the loop, we are saying that as long as the variable count is greater than 100, do the coding in the red block. Once it has processed that block, on the end do line, it will check if the variable count is greater than 100. The do until command always checks the looping condition at the end stage. Therefore, the do until command is always executed at least once. The next command we're going to take a look at is the do while command, and it's all very similar with the do until command. The do while command evaluates an expression and conditionally processes commands accordingly. Again, this command only has one parameter, the condition parameter. Let me explain this example. On the first line of the loop, we are saying as long as the variable count is less than 100, do the coding in the red block. Once it's had processed that block, the end do line sends the program back to the do while command to check if the variable count is greater than 100 now. If it is greater than 100, the program will continue with the line after the end do. The do while command always checks the looping condition at the do while stage, which makes it different from the do until command. The iterate command will stop the processing of commands in the associated do while, do until, or do for loop and passes control to the associated end do. In this example, we are saying that if the variable message is *end, then go to the end statement. The next loop processing will continue while the variable count is less than 100. We are now going to have a look at the select command. This command is similar to its RPG equivalent. It is also known as a case command in some other programming languages. The select command begins a structure to allow conditional processing of groups of commands. The select group is ended with an end select command and must contain one or more when commands and may be an otherwise command. So in this example we can see our start select and the end select commands. We also have our when blocks and at the end an otherwise block. So let me explain this example. Here we can see our first when block. Each when command has a condition associated with it. You can see here I've used the do command to execute a block of coding. So the program will check the when condition. If that's true, it executes that block of code. Once it's executed that block of code, it then moves down to the end select statement. No other when or otherwise statements are actually executed. Control drops out to the end of the select statement. The otherwise command is a catch-all. So if the first when doesn't catch anything and the second when doesn't catch anything, so on and so on, the otherwise will actually get executed. So to summarize, the select statements are very useful. It saves us coding multiple ifs. If this, do this. If this, do that. If that, do that. So a very useful addition to CL programming. So how do we quit loop processing early? We use the leave command. The leave command will drop out of the loop and carry on processing after the end do. So that rounds off our version 5.3 enhancements. To recap, what did we get? In this release we had new variable types, using more than one file in a program, and loads of structured programming features, all very useful. That concludes this module. Let's move on to the next one. And on to version 5.4. As with version 5.3, IBM continued with its enhancements of CL. Let's just take a look at these changes. These enhancements come in two general areas: data definitions and subroutines. Let us take a look at the first one off the list, data definitions. We have a new command, DCL PRC OPT, declare processing options. This new command lets you define compiler processing options. I'm sure we've all seen compiler options that are associated with a certain program, written in the comments section at the beginning of a program, that states how we should compile this program. Well, this command saves us from having to remember how to compile a program in a certain way. For our RPG programmers, this command is very similar to our RPG HSpecs. This command has to be placed within the declare section of a CL program, along with the declares and copyright. And there can only be one DCL PRC OPT command per program. In this example, we can see this new command, and it will specify a subroutine stack of 100. It will run under the user profile of *Owner, and it has an encrypted debug key of get your own. All very useful additions. The next enhancement has been on the DCL command. The DCL command has been enhanced to provide two new features: the ability to overlay one variable with another and the pointer data type. Let's look at the overlaying data first. In this piece of code we can see the first variable defined, full, character 20 long, and it has a value there of QGPL and FSS. The second variable we have there is the library variable. As we can see, characters 10 long. It has to be defined with stg as defined because the system takes care of it, and then we've got a defined variable, and we can see there it's actually pointing to the full variable. So we can see that in the line above. So we'll take the first 10 characters from the full variable. The third variable we have defined there is the object variable. As we can see, this has got the def var keyword specified to full again, but it's starting at position 11. So this time it's going to include FSS and blanks for the rest of it. So we can see this actually split our full variable into two parts, very similar to an RPG data structure. So it's very handy. We don't have to do anything with these variables now if we want to split them up. We don't have to use the substring, etc. So what is a pointer? A pointer variable declaration means that the variable holds a memory address. A pointer gives you an address where a variable and its contents are in memory. Think of a pointer as a postcode. It will tell you where somebody lives, but not what is inside at that address. Pointers are extensively used when calling IBM APIs. You do not specify a value for this parameter. Pointers always have a fixed length of 16 bytes. Let us take a look at this bit of coding where we can show you how to use pointers. So the first line we're going to look at here is this declaration. It's an alpha name, character 26 long, nothing special about that. And underneath it, we've got a pointer, alpha P, and it's actually declared with an asterisk PTR definition. We've also got a string underneath that, 10 characters long, and that's using a storage of asterisk based, and it using a base pointer that actually points back to the alpha P pointer. So anything within the alpha P pointer would actually automatically get re-reflected here into the string variable. So now we've defined our variables, how do we use them? In the first line here, we can see we're changing the variable alpha P to what's in the address, percentage ADDR, or you can type it out in full if you want to, percentage address, what we got in ampersand alpha. Underneath it, moving on to the next line, we've got send program message. So this is just going to display it on the screen, just ready for demonstration purposes. So we're going to display on the screen there the value we have in ampersand string. So we've done nothing with ampersand string. We're just taking it, because it's using pointers, it's automatically given it a value of FormaServe, because it's only 10 characters long, so it only gets the first part of FormaServe. Now moving on a couple of lines, we can see that we're changing a variable there. We're doing an offset of the pointer, alpha P, and we're saying make that alpha P plus 11 characters. So now it's going to move on to 11 characters from where it was. And again, we're looking at on the screen displaying the string variable, and this time it will be system. So we've moved it along, so we're using pointer arithmetic to actually move it on 11 characters, and now we can see that it will be system. So the next one on the list is subroutines. So what is a subroutine? A subroutine is a block of code that you can call multiple times. It saves you having lots and lots of duplicate code within your program. Let's take a look at the example we have here. Subroutines are always coded at the end of your program. So we can see the beginning of one subroutine. So it uses the command sub R and then the name of the subroutine. So that block of code goes all the way down for where we have the end subroutine command. We also, in this example, have a return variable, but as we said, this is optional. So this subroutine has got 10-11 lines of code that will get executed every time we call that subroutine. This is where the subroutine is actually getting called. It uses the command called sub R with the name of the subroutine and then any return value that you need. So the return value from this subroutine get passed back into the variable ampersand count. We can see here this program hasn't got any return values after the subroutine, so the compiler would insert them here for us, which is exactly the same as if we just put a return in there ourselves, which is more common and it makes it more readable. So that is the more common occurrence. And that's all a subroutine is. As we said, we can have many subroutines in a program. So if you've got code that's getting duplicated, it's a lot easier and a lot more readable to put them into a subroutine. That concludes the changes for version 5.4. So let us recap. What did we get in version 5.4? We had data definitions. This included pointer variable types, address built-in functions, percentage offset built-in function, declare processing options, and the big one there, subroutines. So with these additional features, CL now can address a wide range of applications that it couldn't in the past. Very useful. And onto version 6.1. As with version 5.3 and 5.4, IBM continued with its enhancements of CL, albeit a lot quieter than the last two versions. Let's have a look at these versions. There are two main changes to CL. They are the close command and the include command. Let's take a look at these. The first one to take a look at is the close command. We can see here we've got the declare file where we're looking at our journal file. So on disk it is UTJRN01P, and we're going to use an open ID within the program, but just call it journal. That makes it a lot easier for us to read. The next line down, we're going to just receive the first record from that file, so we do the receive file, and then after that we can see the close command. So this is the new part. So before, if we wanted to close a file, the journal file, we would have had to close the program, but now we can explicitly close that file, which makes it very handy if we've got more than one file open. Remember, we can have 5 open files within our CL now, so managing those makes it a lot easier. And next we have the include statement. The include statement is the same as an RPG copybook, a PHP or Node.js requires statement. It will insert source from one other source member into your program. This is very handy for common pieces of CL. For example, if you have some standard error handling that is in every CL program, place that code in a separate source member, then include it within all your new programs. If you ever have to go back and change the included source, because it is included at compile time, you will have to recompile your programs. Here we can see some source being included. Here we have a source member of error 01, and that lives in source file in the training library in QCL LE source. So that will get included at that point in the code in this program. So let us now take a look at the spool file that's been created from this compile. I'm using ACS, so it's opening up my spool files in PDF, which makes things nice and easy. So we can see here, if we come down the spool file, we can see it's included the file declaration of our journal file, and then it's going on start include from source member in the source file. So we can see the first 4 declares there from that source member. Let's page down the file, and we can see the rest of it right down to the end of that source, and then it carries on with my program. So it's included that source exactly what I've said to within my source member. So it has to be in the correct order. Because I'm using declares there, make sure it's within the declaration section. So that concludes our 6.1 enhancements. Yes, there was only a couple compared with the other 2 releases, but 2 very useful commands. We had the close command, so we can close individual files, and the include source from other source members. 2 very useful additions to this programming language. That concludes this module. Let's move on to the next one. And now let us take a look at version 7.1. IBM has given us 3 CL programming enhancements in this release. We have longer integer CL support, nested include support, and new built-in functions for character strings. Let's go through these one by one. So in this bit of coding we can see 3 variables defined as integers. The first one, &count, second one, &pos, and the third one, &length. So the first one, &count, hasn't got any length to it, so it will be defined as 4 bytes long. The second one, POS, has been defined with a length of 4. And the third one, len, has now been defined with a length of 8. So this is very handy if we're calling IBM APIs that need a long integer. So this will use 8 bytes for ampersand length. The next one on the list is the nested include command. The include command, as we know, was included within version 6.1 of the operating system, and it's been enhanced in 7.1. So we can now include nested enhance. So what does that mean? So we can see this bit of code here. On this line here, we've got the include error C1. So that piece of code there can actually also include some includes, where before it couldn't. So that you can have nested includes. So C1 can have nested includes, and another include down the bottom of the coding, error C2, which can also include nesting, and that nesting can have nesting as well. So there's no limit to the amount of nesting we can actually have. So be aware of that. Can be make life very difficult for debugging, but can be very, very handy. And the third one on the list is string handling. These are new built-in functions that IBM's added, all very, very handy, makes them very, very similar to RPG. So the first one we've got on the list is percentage check. Percentage check will check for characters in a string. The next one, percentage check R, will check reverse for characters in a string. Then we have percentage scan. Percentage scan scans a character for strings. Percentage trim trims characters from a string, both from the left hand side and from the right hand side. And to follow on from that, we've got percentage trim L, which trims characters from the left of a string, and to follow on, obviously we've got percentage trim R, which trims characters from the right of a string. Let's take an example of a CL program now and show you how these actually work. Percentage check will return a number where it finds the character we're searching for, but is the position after. So we will find that character, then add 1 to it. So in this line we are changing ampersand length to be the value, then using percentage check with the pound sign in a number. Find the first position that doesn't actually include a pound sign. So in this example, ampersand length will have a value of 2, the second position. So the next one is percentage check R. Percentage check R checks from the right of a string, then going towards the left where it can't find that character. So in this example, we have the text there, which is $10000 space CR. So it's going to check for the sign, where the sign is CR, the first position from the right that it can't find the CR. So in this example, percentage length will now have a value of 8. The next one to look at is percentage scan. So percentage scan will find exactly what you're looking for. So in this example, we can see we're using percentage scan on the string to look for the percentage sign. So the first position it finds it in is position 17. So the next one on the list is percentage trim. Percentage trim will trim characters from both the left side and the right hand side of a string. So we can see in this example, we've got a variable ampersand amount, which has got lots of spaces in it, it's got lots of asterisks in it, and it's got a value in the middle. So what we want to do, we want to strip out these asterisks and the spaces as well to just give us the actual value it's got in the middle. So that's what percentage trim is doing here. So percentage trim, percentage amount, and trim out spaces and asterisks. So make sure you put the spaces and the asterisk in there, and the result will now be 10.55. So percentage trim trims out from the left and the right, whereas percentage trim L trims just from the left, and percentage trim R trims just from the right. So that is the end of the enhancements for 7.1. Let us recap. IBM has given us 3 CL programming enhancements in this release. We have longer integer CL support, nested include support, and new built-in functions for character strings. With these enhancements in 7.1 and in the previous releases, IBM really has made CL a very good programming language and capable of doing most things now that RPG traditionally has done over the years. That concludes this module. Let's move on to the next one. Let us now move on to 7.3. In this release, IBM really enhanced the built-in functions that they've been adding over the last few releases. We're going to go through those one by one. Let's take a look at the first one. IBM has added the ability to convert strings to upper and lower case. So they've introduced the percentage upper built-in function and the percentage lower built-in function. The first one we can see here is changing the value of the variable ampersand string to uppercase for the variable ampersand CO lower. So we now end up with ampersand string as all being uppercase. And to follow on, in the next example, we have percentage lower. So in this example, we're changing the value of ampersand string to be lowercase in what we've got in the variable ampersand CO upper. So the string will now be FormaServe all in lowercase. The next couple of enhancements to the built-in functions is done with percentage decimal and percentage char. These two have been added so we can easily convert from decimal to character and vice versa. In this example, we can see we're changing the variable ampersand answer to the value percentage decimal of the points variable with 5 places, with 2 of those being decimal. So percentage answer will now be minus 123.45, and it's padded it out with zeros, as you can see, because percentage answer is 10 long with 5 decimal places. In this next example, we're changing a variable ampersand count, which is obviously decimal, it's an integer, back to a string. So we're now using percentage char to move back the other way. So at the end of the day there, after this line is executed, ampersand string will be 50. It will be a character. The next one on the list of these built-in functions is to do with integers. Signed integers and unsigned integers. So they've added the percentage int, percentage integer, and percentage uint for unsigned integers. In this next example, you can see we're changing ampersand answer to the value, the integer of ampersand points. So ampersand points was minus 123.45. After this line is executed, answer will now be minus 123. So it's just taken the integer value of ampersand points and placed it in ampersand answer. It will round up or round down the value for you. And now to make an unsigned integer, we use the percentage uint built-in function. So we're using that on the points variable and placing it back in answer. So the ampersand answer will now be just 123 because it's unsigned, it's done the rounding up and down and makes it a whole value. That concludes the enhancements for 7.2. So let us recap. What did we get with this release, 7.2? We had upper and lowercase conversions, converting character and decimal strings, and converting integers and unsigned integers. So very, very useful additions to the CL programming language. That wraps up our video on CL enhancements up to version 7.4. There has not been any further changes to the CL programming language. But as you can see, IBM really has enhanced CL to be more than capable programming language. Get rid of all those GOTOs now. Thank you for watching.